One question, how many of you are Ruby developers? Is it a half? Okay, that's great. So, I don't know if you have the memo, but Ruby is dead. I'm joking. Ruby is alive, and it's more alive than ever. And there are some interesting opportunities for Ruby that I want to show you today. But first, who wants to play a game? Not this one, but it's also a great game. Seriously, I need a volunteer. Great. Come to the stage, please. Let's pretend we don't know each other. What's your name?
Adam.
Okay, you'll be Alice. Yeah, so basically here's the game. You can start the game here, you can join the game, but don't do it right now. I'm going to show you what the game looks like here. So, can you stand here maybe? Okay. So we'll be playing a game of tic-tac-toe, and here I have the browser version of the game. There is a Bob logged in. There is a Alice logged in. Alice also have the game on an iPad. And could you start a game? Did it work? You can try clicking once again.
I want to play.
Let's try to turn it off and on again. Maybe this will work. It happens every time. Okay. I'll refresh the games here as well, just to make sure. Okay. Oh, it might be using the network, the different network. So it's going through the internet, and the network might be slow. Oh, God.
You can switch to the other Wi-Fi.
I think it's on the other Wi-Fi. Okay. Yeah, I was afraid of that. All day. Okay, we can play a game actually in the browser. I think it might work better. So, okay, so basically you can start a game as Alice, for example. Okay, then in the other browser I join the game. And basically it's your turn, so. I don't know, like, I can let you in. Okay, thank you. So basically, thank you. You can be Adam from now on. Okay, so when the internet is working, it actually works also on the mobile device. I can show it to you later, maybe at the party. But yeah, so we have this game that works in the browser, and it connects through the API with a Rails application. And so when we have multiplayer games, so let me connect my remote. When we have multiplayer games, we have traditionally, there are two facts that players expect snappy interface. This is one fact. And the other is that players cheat. So when we have a game like tic-tac-toe, we usually need to implement logic both on the client side to have the snappy interface and on the server side, so we can validate every move and we make sure that the game is fair for every player. That's it. So it used to mean a lot of redundancy. But now we have the technology. Now we can write cross-platform apps. So if you've been to Michal's talk yesterday about Xamarin and cross-platform development on C#, we can basically do the same thing or similar thing in Ruby, but for now, we need to use quite a lot of duct tape for the solution. And I want to show you what we can do using tools that we have. So what are those tools? There is opalrb. Does anybody knows that? It's not very popular, but opalrb is a Ruby to JavaScript compiler. It's pretty performant. Great reaction. It's not version 1.0, so but it's actively developed. Developers of opalrb use it in production. It has out-of-the-box Rails integration. You can, instead of working with CoffeeScript, you can write actual Ruby that works in the browser. And there are interesting libraries that start to show up. For example, there is Vienna, which is something like Backbone, but for Opal. There is something like Meteor server for like written in Ruby that you can basically reuse the same code on both sides. And it works. So this game actually is written, the browser side, works in Opal. There is RubyMotion. And this is pretty cool, because RubyMotion is also a compiler for Ruby, but it is compiling Ruby to Objective-C runtime. And it works pretty well. So for right now, there is almost version 3.0, and it's pretty stable when it comes to Objective-C. So a lot of applications are already written, and if you, it is a great alternative for Objective-C or even for Swift, because we can use some of our Ruby code in Objective-C libraries. One cool fact is that Android support is on the way. Unfortunately, it doesn't compile my application yet. I tried it before, like yesterday, because they are updating it constantly and they are fixing the bugs currently. But it's not ready for production, but it looks pretty good. So it has a native performance, so it's not any kind of layer between Objective-C and Ruby. It's just compiled to the Objective-C runtime, so it uses exactly the same thing as Objective-C natively. And it's widely used in production. We also have a new player. We have mruby. And this one is pretty cool. I haven't used it so much, but version 1.0 was released this year. And mruby is basically a Ruby for embedded development. It is a virtual machine that you can embed in pretty much any C program or any library that can be linked, like any C library that can be linked. In other words, any program can link a C library that provides mruby virtual machine. So you can actually embed your Ruby into Windows programs, into Linux programs, into Mac applications. There is also like version of mruby working in Objective-C. You can even use it in Arduino Duo because it has enough RAM. It requires like 96 kilobytes. Unfortunately, it won't work on Commodore 64. Too little memory. And it is promising for developing Windows applications. But the thing is any of them really a Ruby? There are differences. For example, RubyMotion doesn't have any require at runtime. You can't evaluate a code, so because Apple doesn't allow any runtime code creation. So you cannot eval, you cannot parse any Ruby code and create meta, like do meta programming with that. But you can use any meta programming that uses blocks. So you can define methods, you can do quite a lot of things. Some methods in RubyMotion have incompatible names. If any one of you programmed anything in Objective-C, you know that if a method has two parameters, the parameters are split between method names. So instead of, let's say you have a method move by x and y, so the method name in Ruby would be move by and then parameters. But in Objective-C and RubyMotion using Objective-C would be move by x, then you put x, and y, and then you put y. So actual name of the method is move by x and y. So if you are doing something like sending messages to your RubyMotion code, you need to make sure that you are using proper names of the methods. The other difference is that threads are actually working. This is a good thing, but it can lead to unpredictable bugs if you had an application that you thought was thread safe, but it's not. And the memory leaks are possible because Objective-C and RubyMotion uses reference counting. There is no garbage collection in iOS. So it leads to some tricky things when it comes to passing blocks around because they can keep the references for variables. But you can get a lot of helps in the forums, and it's not actual problem anymore, I think. With OpalRuby, there is no require at runtime because it's not really makes sense to require files in your browser. Strings are immutable. So strings are translated directly, like Ruby strings are translated directly to JavaScript strings. So you cannot modify them. Symbols are strings. So this is a difference because there was no better representation for symbols that would be performant in JavaScript. So they just basically did a shortcut like that. Regular expressions are different. All numbers are floats, JavaScript. And it used to not have for loop for some time, but they finally implemented it a few months ago, so there is for loop already. mRuby, again, no require at runtime unless you implement it yourself. No gems. There are things similar to gems. They are called MR gems, but you need to compile them into actual Ruby compiler, into actual Ruby executable. So MR gems are used to put features into mRuby that were removed from it. For example, you don't have regular expressions by default, but if you add an MR gem that gives them to you, you will get them. There is no big number support. So basically, mRuby is designed for the size of the program, and there are some drawbacks that, well, there are some differences caused of that. And because of it's optimized for size, sometimes, well, quite often, it's faster than MRI. So this is a good thing. So is any of them really a Ruby? That's a good question, and my answer for that is the Ruby enough. Basically, there are some differences, but if we cut corners, we'll get cross-platform Ruby. So a common subset of Ruby that works on OpenRB, in RubyMotion, and even in mRuby. So if we use that, we could write cross-platform applications. Does this diagram ring a bell? Anybody? Some kind of architecture? Hexagonal? So basically, that's an evolution of the idea. I'm not sure if it was Uncle Bob's idea or he just popularized it. Basically, hexagonal architecture tells you that you keep your logic of your application inside of the pure Ruby objects or pure Java objects or pure anything. And if you have something that changes, like database or graphical interface, you create an adapter for that. And you call the adapters, create an interface for these adapters, and you use them from your logic, or you use your logic from outside of that. But we are talking about different platforms here. You cannot write adapter for whole iOS. There are multiple subsystems there. So actually, this diagram should look like that. And this is closer to the truth. So basically, the idea is to separate different subsystems, like common parts of your application logic, and use them in your applications. And I want to talk about the interactions because this is something that is interesting. So basically, how those subsystems can interact with each other. So first one is the easiest one. We have internal interactions between those plain Ruby objects that that your domain logic is composed with. And you can use clean architecture, hexagonal, DCI, microlibraries, cowboy coding. This is your kingdom. You can do whatever you want here. The other thing, the other type of interaction is access from outside. So, for example, your cross-platform code is providing a translator service. For example, you give it a string or a symbol, and you get the translation for it. And basically, you could create an interface for that and use it in iOS just to provide the text for labels, or you could use it in Rails or in OpenRB and use it for like titles or something like that. It could be used also for logging. For example, you could have a common interface encapsulating KISS metrics and use the same interface for different purposes on each platform. So this is an example of accessing your cross-platform code from outside. The other type of interactions is driving your application from inside. This is when your cross-platform code is issuing orders to your application. So let's say you have a wizard or some kind of interaction that you have in common in Android or iOS, and you can encapsulate that. So you just have steps for the wizard or something like that. Or you have like some kind of image editor controller that can animate some view. And this will be implemented differently on multiple platforms, but the interface can be the same. So your cross-platform code can drive your application from the inside. And the last part, but one that is most tricky, is the asynchronous communication. So when your systems are interacting with each other and need to need to communicate asynchronously. For example, you have a, let's say you have a to-do item. So this is a plain Ruby object. This is actually how the logic of the application would look like. It would be composed from simple objects like that, without any database or anything. And you just mark it as done. And we want to save it afterwards on each platform. So the question is, what does the save mean? It depends. So our Rails application would actually save it to database. Our Objective-C application could save it to database or could post it via HTTP to our Rails application. And our core domain doesn't care about that. It just marks item as done. So saving in this application can happen asynchronously. And we have different ideas how we can implement that. So I'm going to skim it a bit because I have 10 minutes left. So basically, we could use abstract interface, we could use notifications, or even aspect-oriented programming, and there are differences between them. So, for example, in abstract interface, we could extend our cross-platform code to know something about how to save things. For example, it will know that there is an object called saver that can save our to-do item. We can inject that object and just save them after to-do is marked as done. And for example, this saver could use database adapter or REST adapter depending on what is needed on the platform. But with this abstract interface, our cross-platform Ruby needs to know that there is something from potentially outside of our domain, so needs to know about saving. We also could have some kind of notifications, so we could have events, callbacks, whatever you call them. And here, we don't need to know that something is going to save the to-do. We just need to inform it about events. So we tell some object, some listener, that our to-do was just marked as done, and do whatever you want with that. So it could look like that. For example, on one platform, we could mark it as done and then save it to database. On the other platform, we could mark it as done and then post to API. And this gives us the ability of not defining the interface and just listening for events. So we don't need to change our like cross-platform part of the code that much. We need to add the ability to triggering some events, but we don't care what happens next. And yeah, there are some drawbacks to that, and some pros, some cons. And there is last part gives us the most freedom that we have, aspect-oriented programming. This is similar to notifications, but in this case, we don't need to touch the internals of our, we don't need to change our cross-platform code, but we use some kind of aspect-oriented library of choice, and then we add a callback from outside. So we actually inject some methods from outside of our, so we do that from each platform. And for example, in Rails, we would inject that code that saving to database would happen after marking the to-do as done. And this can be used when we really don't want to touch the code that is already written and implements our logic, but it has drawbacks like our platforms need to know about internals. Platform needs to know that the to-do is somehow marked as done. So this could happen pretty deep inside of the application, and we would need to know the place where we could attach this callback. So every of those ideas have some different drawbacks, and you could choose one that fits your applications the most. In this application, I used the abstract interface with some notifications, and it worked pretty well. So where to keep this logic? We could basically pick it from one project, paste it into another. We could share it in a directory structure, or we could create cross-platform gems. So for those who don't program in Ruby, gems are basically libraries. And if we extract our logic into our gem and then reuse it on those platforms, then we can version it, and we can we have a common place to store our code, and it's actually pretty convenient. It requires a little bit of work because on each platform gems work a bit differently, but in practice, it is only 20 lines of code. So I written a blog post about that. I can give you a link after the talk. So how much time do I have? 5 minutes left. Great. I can show you the code. So here I have a directory with different versions of the application. So this is iOS application written in Ruby Motion. This is Rails application. Rails application also serves the Opal RB application. So inside of JavaScript, I have Ruby files. That's pretty cool. But the logic of the application is here. It's in a gem. It's called turn-based because it's actually not only the tic-tac-toe game, but it's a platform for any turn-based game. And for now, only tic-tac-toe is implemented. So here, I have only plain Ruby objects. There is a board, there is a game, there is a move, there is a player, there is move outcome, and so on and so on. There is a so those are abstract interfaces. There are some concrete classes in tic-tac-toe that implement the rules of the game, but there is no database here, no graphical interface, no such thing. So every interaction that happens between the platform and the game happens through this class. So first, we have interactors. So we can initialize the interactor with an adapter. An adapter is something that implements saving, and it can trigger events, and it can add callbacks on the events. And it's pretty simple. So it implements every interaction that I have in the game. So if I start the game, interactor creates the game object, it starts the game object, so this is still pure logic, and then tells adapter that the game has been started. And adapter can then trigger something. So I can show you, for example, how the REST adapter looks like. So basically this is the this is the difference. So this is database adapter. It is used in Rails. So it finds the database active record object. It creates an active record game object. It adds players to the game and then saves it. And after that, it triggers the game started. And the REST adapter, this one is used in iOS, I think. It posts the JSON representing the game to the Rails API. And after everything goes well, it also posts it triggers the game started event. So actually, they do basically the same thing from the interactor point of view. And this is how we use it in Rails. So this looks a bit different. So this is a create action. It creates a game. And first we add a callback on game started. So it will be called when we actually save the game and we add players to the game. And when it finally happens, we can respond to the with JSON representing our game. And we finally tell interactor, start our game given the parameters. And it will do the work. In case of REST adapter, we also we add a callback to the interactor on game started, what should happen. In this case, we just reload games and we start a game. And yeah, and that's basically it. But we use a different adapter in the iOS version, and we basically use the same thing in Opal RB. We also have a REST adapter that can post things to the Rails side, and it basically works. And adding new game is like changing a couple of classes. Adding new platform, provided that platform will work. So when finally my application compiles on Android, it will be like 300 lines of code, and only like a couple of places will use interactor class, and I will need to implement adapter, and that's it. So basically, it's not that simple yet. So it's not the Xamarin that we've seen today. We don't have ready components, but we already have tools, and they will get better. So basically, what I'm saying that is that Ruby is alive, and we are in a pretty interesting place in history, because it's taking over the world, one platform at a time. That's all I've got. Do we have time for any questions? I assume that yes, so ask questions. Come on, don't be shy.
Do you know how they're planning to implement it on Android? Will it be like a bundled runtime, or compiled to Java and then compiled to whatever?
So I don't know many technical details, but it is compiled in the quite like in the lower layer. I mean, it's pretty close to the machine, so it creates the binary version of the classes. It basically tries to compile Ruby to the compiled version of Java classes, and it actually runs in the virtual machine. So the idea behind Ruby Motion is to provide you performant compiler that can, compiler that can create performant code. So in Objective-C, it's like really, really close to the native performance. And in Android, it's when it works, it is also really pretty performant. So you don't have any delays, any just-in-time compilation. It just compiles it up front. Like you have just-in-time compilation from the normal Java virtual machine, but basically it is the same like compiling Java classes.
I have two questions. The first one is, have you, for the communication between the iOS app and the Rails app, have you considered using like protocol buffers or something like that, so that you would cut on the JSON boilerplate?
Yeah, that would be actually pretty good idea, I think. So I used something that was simplest. So communicating with JSON works on every platform. Yeah, I could use probably even some WebSockets, for example. That's or basically protocol buffers.
Cool.
That could work.
And the second question is kind of boring about the project structure. Do you have a Git repo for each app, or do you have like one Git repository for all of them? And like how you deploy
Yeah, so
that?
that's a good question. So right now I have a separate repository for each platform and a separate repository for a gem. But for development, I would recommend keeping them in like the one directory, and because it's much easier to develop it like that. Probably in bigger teams, it might be a better idea to keep all of them in one repository, because when you change, for example, interface on one platform, then you can, the visibility of that change is better. It's actually Michal Cheers' idea. We talked about that yesterday. So yeah, I think it's better to. It would be better to keep them in one repository, but it was better for me to start like that, and it's not that bad idea, but in long term, probably I'll go with one.
Okay, so what's the story with regular expressions? Because this is an important feature and there seems to be all kinds of issues with it.
Yeah, so basically regular expressions in JavaScript are different than in Ruby, and regular expressions between C# and JavaScript are also different. And so basically Opal compiles Ruby to JavaScript as it is and uses things that are already available. So it uses native regular expressions. And yeah, sometimes you need to be aware that what you write in Ruby using your familiar regular expression syntax could work differently in JavaScript. For example, like you would have problems when you would like to match things on a separate lines.
Okay, so what's the solution then? Are there some native libraries for those languages?
Not yet. So this is pretty experimental stuff, actually. So for now, my solution is the same as in general idea. So cut corners and use only common subset of functionalities. But if there will be there are some libraries that try to make Ruby from JavaScript. So probably if somebody creates performant regular expression engine, we could use that. But for now, yeah, it's cutting corners. Okay, I think that's it. Thank you very much.